Okay, so the next set of identities that we're going to talk about are the cofunction identities. The cofunction identities are complementary. The cofunctions of complementary angles are equal. So this is where the names actually kind of make more sense. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. And then what you're seeing is how they are complements. So the sine of theta is equal to the cosine of pi halves minus theta. The opposite is then also true. The cosine of theta is equal to the sine of pi halves minus theta, and so on. Well, we can prove this to ourselves real quick. I'll show you by thinking of a right triangle. So if I draw a right triangle, for example, and let's call this theta, and let's call this alpha, and this will be x and y and z. So just to show you real quick the sine relationship with cosine. Well, I know that, for instance, let's say theta, I know is 90 minus alpha. Okay, that should hopefully make sense. All the angles in a triangle add up to 180. This is already 90, so I'm only left over with 90. Okay, well, I know that from this picture that I've drawn, the sine of theta is x over z, but that's also equal to the cosine of alpha. And I know the relationship between theta and alpha is theta is 90 minus alpha, or alpha is 90 minus theta. So here I can see where those cofunction identities come from. I could write out equations like this for the rest of them as well. You can do that on your own if you want to prove it to yourself. So, find the cofunction of the following. The sine of 72 degrees, the cosecant of pi thirds, and the cotangent of pi twelfths. So I want you to pause the video and unpause it when you have your answers and you want to check, or if you get stuck. Okay, so this is what we're looking for. If you were confused, or if you want to check your answers, the sine of 72 degrees is the same as the cosine of 90 minus 72, which is the cosine of 18. And I should have a little degree symbol so we know that's degrees. I could type this into my calculator. I know it's not a nice number, so I'm just going to leave my answer like that. The cosecant of pi thirds is the same as the secant of pi halves minus pi thirds. Well, pi halves minus pi thirds is pi sixths. So the secant of pi sixths is 2 root 3 over 3. I know that from my unit circle because this is an angle on the unit circle. The cotangent of pi twelfths is the same as the tangent of pi halves minus pi twelfths, which, if I do that, I get the tangent of 5 pi twelfths. This is not on my unit circle. I could type it into my calculator, but it's not going to be a nice number, so I'm just going to leave my answer. Okay, last example. A ramp 20 feet in length rises to a loading platform 3.75 feet off the ground. What is the angle of elevation of the ramp? So, we need to make sure we understand, well, what does it mean? What are we saying when we say angle of elevation? Well, angle of elevation is always an angle looking up from the horizon. So, an angle of elevation would be this angle. So if this bottom line here is the horizon and I'm looking up, this is the angle of elevation as opposed to an angle of depression. So the ramp is 20 feet in length. So I'm going to say that this is the ramp and that's the 20 feet. Rises to a loading platform 3.75 feet off the ground. So then you're going to have some platform up here. So this is 3.75 feet. So what is the angle of elevation of the ramp? Well, we need to use trig to find the angle. Which trig function do I want to use? If this is the angle, what is this side in reference to that angle? Well, this is the opposite. This is the hypotenuse. So I would recommend sine. So I know the sine of theta is 3.75 over 20. Well, we actually want to get an answer here, though. So how do we solve this? We do the inverse. So I know theta equals the sine inverse of 3.75 over 20. So if I type this into my calculator, we can type in, and let's have our answer in degrees. Now it didn't specify, but most of the time if we're dealing with applications, angles are more useful in degrees. And I'll explain once we get our answer. So we're going to type in second sine of 3.75 divided by 20. And so we get 10.807. So this equals 10.807 degrees. So now going back to, well, this is more useful to most people. If I tell you something is a 10-degree angle, you can probably picture that in your head, what that kind of looks like. But if we were in radians, and we type this in, we would end up with 0.189 radians approximately. So telling you something is a 10-degree angle or that it's 0.189 radians, 10 degrees probably makes more sense most of the time. So that's why when we're dealing with word problems, most of the time we want to have our angles in degrees. Now that's not always the case. It's, again, most of the time. Again, this was a word problem though, so we want to answer in a phrase or a sentence. So the angle of elevation is approximately 10.807 degrees. Now, I don't know if I mentioned earlier, but most of the time, unless it's specified otherwise, round to at least 3 decimal places. Okay, so we want to make sure we understand our right triangle trig. We want to make sure we know and love and understand and respect our 6 reciprocal, our 2 quotient, and our 3 Pythagorean identities. And then we also want to make sure we understand the relationship between the cofunction identities.